Hey everyone, I am Jay Ohms. I work at 37 Signals. I lead the mobile team there, and I'm a programmer primarily on the Android side as well. Well, before we get into Strada, there's an important question. I know some of you are asking, so let's just get it out of the way right now. Did you seriously tease Strada when Hotwires launched years ago to get my hopes up and take a really long time to finally launch? And I've had to wonder what it is, how it works, and if I should care for so long? Yes. And now that we have that out of the way, I would love to tell you all about it. So a little bit of, I'll start high level before we get into the weeds. So the web. As you all know, the web is really great at a lot of things. It's broadly accessible. You can develop really fast, prototype things really fast. It's great at displaying server-driven UI. And your changes are really quick and easy to deploy. If some of you are mobile developers, you are very familiar with the long, slow review processes being a painful part of the job. Native apps. They are optimized for small screens. You can have a really high-fidelity experience. You can take advantage of the platform APIs and conventions. Apple and Google have done a great job giving you really great platform APIs that we all can use. And you also get to use UI components for free, more or less. So at 37 Signals, our apps are hybrid. They're built on the Turbo native libraries. And our native, we have two types of screens. We have native screens, and those just render UI from JSON endpoints. And when we've got a native screen, we can control the entire screen. Everything is up to the native code. We can do anything we want. We also have WebView screens driven by Turbo, and those display web content within a rectangle on the screen, and that looks like this. So while we can decorate the WebView with some native Chrome around the WebView, there is a problem. And that problem is there's a disconnect between the WebView on the screen and the native shell and features of your application that you may want to deliver. There's no easy way for the native app to know what's going on in the WebView. So for a long time, we built our apps on the Turbo libraries for a long time, Basecamp and Hey primarily. And we knew we needed a way to communicate with the WebView back to the native app, and then from the native app back to the WebView. And we went through several approaches and mistakes along the way. One thing we did was we would package app-specific JavaScript within our native apps to manipulate and query the WebView DOM. This is a really fragile approach, and it would break if we ever changed the web app, which web app, your web app may you may change it really frequently, and so this is a major problem when the only way to fix a bug is to ship a new app update and wait for review times. The native apps also don't know when there are state changes in the WebView DOM. So unless you're packaging very specific app domain knowledge within your native apps about your WebView app, it's really difficult to know what's happening in the WebView. Also, at 37 Signals, we have a web team. We've got web programmers and designers, and then we have our mobile team. We've got mobile programmers and designers. And we work independently. We do work together, but we also work independently. And it was really difficult for web designers and programmers to know when changes to the web app would negatively impact the native apps. So we knew we needed a solution to this long term. We had an approach in Basecamp for a long time that we knew kind of worked, but it wasn't great. And so we set out to create an approach, a framework that could solve these problems for us. And we knew we wanted it to be a bridge between your web code and your native app code. And we knew we wanted it to be a component-based framework because that was the way that we saw that we could scale. As the web app and native apps scaled, we could, if things were componentized, we could cleanly separate the lines between different features. We had some rules about what we wanted to, how we wanted to solve the problem. One of them was the apps must not know anything about the DOM markup on the page. The knowledge that the native app has should be completely divorced from the actual DOM in the WebView. The native app can't package any app-specific JavaScript in the app. The native and web apps should communicate together. We use JSON for this in Strada. And the web app should be able to send state changes from the WebView to the native app to inform it about changes. And the native app should be able to reply back to state changes back to the web. And the other thing we wanted to do was, if you have a Turbo native app, one of the things you'll realize is you want to launch a new feature, and you can push that out and deploy your changes immediately on the web, but it may take 1, 2, 3, a week to ship out your app update. During that time, how do you transition from old clients to new clients? And so Strada uses a opt-in component system where the behaviors change based on whether the native apps support certain components that the web app already knows about. We also want to be able to bridge web UI to native UI in clever ways. We already had a lot of things that we were doing on the Basecamp side, and so when we were building Hey, we knew we wanted to build even more sophisticated native features that were driven by the web app. So all those things combined, we spent some time and we developed Strada. We've been using it in Hey ever since Hey launched in 2020. And it's a set of libraries across all the platforms to create fully native controls in your hybrid mobile apps driven by the web. What do I mean by driven by the web? I mean your web app determines when and where native controls show up in your native apps. The native apps don't get to decide where native controls show up. Your web app actually can control that. Strada leverages stimulus directly, so it gives you the same power in your web components as you're familiar with stimulus. All right, so let's look at an example. Here's a screen in Hey. This is a screen to edit your profile. Nothing fancy here. If you notice at the bottom, there's a Save button. This is in the WebView. This is a WebView screen. One of the in mobile apps, it's quite common to have your submit buttons or save buttons or next buttons up in the top right toolbar, app bar area. And that's convenient for a few reasons. This is an example of when you've got the virtual keyboard open. You can no longer see the Save Changes button. And so the user has to scroll. There's also like blank empty space up in the top right corner. So let's improve it. We're going to move the Submit button to the top right of the app bar. We're going to hide the Submit button in the WebView. We're going to notify the web. The native app will notify the web app when the native Submit button is tapped. And the web Submit button will submit the form as if the user had tapped the WebView button directly. So the web form. Let's say this is stripped down to the basics. So let's say you've got a web form element with a submit input. Let's hook this up to Strada and make a web component. So the first thing we're going to do is we're going to add a data controller attribute just like you would do in Stimulus. We're going to tie that to a bridge form component. And we're also going to set the submit button as a target for the component. So to create a web component for Strada, you're going to extend the bridge component class. The bridge component class is itself an extension of a stimulus controller. So you have all the same things in stimulus that you would have in a bridge component, but the bridge component adds another layer of Strada-specific functionality that you can use. One thing you need to do is give your component a name. This is just a plain text name that both the web app and native app will agree on. And it's used as an identifier between the two. We'll set up our target for the submit button. When the submit button is connected on the page, we're going to do a few things here. So the first thing we'll do is we'll wrap the submit button target in a bridge element. The bridge element is a class that gives you some Strada-specific behaviors and features for Strada, for your web components. One of the things that you can do is you can easily set up titles for your elements, and you can reuse your own web titles, or you can come up with Strada-specific titles, attributes for your native apps. So for example, the web app button says save changes. If we wanted to just say save, it'd be trivial to do that with extra markup on your elements. This is where things get interesting. We are going to now send a message to the native app. And let's look at the different parameters here. So first we've got connect. This is the name of the event that we're going to send. Every message has an event name. And this is something that your web component and your native component are just going to agree on the different types of events that they support. The next parameter is data in JSON format. So we're going to pass along this name of the submit title to the native app. So it's the title of the submit. The third parameter is a callback. It's a callback that will get triggered when the native component replies back to the web component, and specifically back to this message that we're sending right now. Oh, one thing. If you look at what we're doing here, when the native component replies back, we are going to click the submit button on the form. So it's very simple here, but the nice thing here is we're not changing anything about the way this form works. We're not changing validation. We're not changing how it submits to the server, anything like that. All we're going to do is pretend that the user clicked the submit button when in fact it was proxied through Strada. So let's look at the bridge message that is sent if your native app supports the form component. Let's break it down. We've got an ID. This is just auto-generated by Strada on the website. You don't need to really worry about it. We've got the name of the component, which is form in this case. We've got the name of the event, which is connect. And we got the data that's sent along. So you can see here, we got the submit title. And we've also got some metadata that gets passed along as well. And this makes sure that we never send, or we always send the correct messages to the correct components on the correct screens. So that's what this is used for here. Let's go to the native side. So we're done. We're done with the website. We've done everything we need to do for the web component. I'm going to give an example here in Android. I'll give an example in iOS later so you can see both. So we're going to extend the bridge component class on the native side. This is in Kotlin. We have to implement the onReceive function here. And this is when the component receives messages for this component. And when the message event is connect, we're going to handle that. And here's what it will look like to set that up. So First, we're going to get the data from the message. This will be a deserialized JSON. And you can look down below right here at the bottom, lines 23 through 26. This is a standard way of setting up deserializing data in Kotlin. We're going to create the native toolbar button and place it in the toolbar. I've got this for the sake of the presentation. I don't have all the code here. But if you want to look at our Turbo native demo apps, we've got all this code and more as examples. So we created our native button, and we put it in the toolbar. We're going to set the text as the title coming in from the data in the message. And then we're going to set an on-click listener for that button. Then what we're going to do is when the user taps the button, we're going to reply back to the connect event message that was last received. And you can also optionally pass data along when you reply, but we don't need to do that here. All we need to say is the user did the thing that we need to, and we're going to reply back to the connect message. So connecting the dots, there's some initial setup to do on the native side, initializing the bridge with the WebView instance, updating the WebView user agent screen so the backend knows what components are supported. We're going to delegate the Turbo lifecycle events to a bridge delegate class and register the form component. All this stuff is in the quick start guides for Strada iOS and the Strada Android libraries. This is one-time setup stuff that you need to use to set up, and we'll probably improve this process a little bit in coming updates. All right, so we've built the web component, we built the native component. How do those things connect in your web app? So Strada, both the native app declares what components it supports, and the web can look at and see and change behaviors based on what components are supported. So one thing that's done, Strada does automatically for you, is it'll update your document element in your web app with both the platform that's being used for the Strada bridge and the supported components. So that will always live on the document element, and the Strada web library takes care of that for you. We also recommend updating your user agent to include the supported bridge components. We've got helper methods to make that easy for you to do. This way your backend can know what components are supported if you ever want to do conditional logic on the backend. All right, so back to the example. What are we missing? The button is up in the top right corner. If we tap it, it will it will reply to the message, and the web will click the submit button and submit the form just like it always did. But you can see here we've also got the web button still there. There's an easy way to fix this. We're going to use the registered bridge component to have scope CSS here. So for any, it would look just like this. For any submit button inside of a bridge form controller, whenever whenever the form component is supported in the native app, we will hide the submit button. And so then whenever, this works both forward and backwards compatible. So if you launch a new feature and you've got a web form, but the native app doesn't support the form component yet, you'll still see the web button. If your native app is updated to support it, we'll show the native one instead. So then it'll look like this. So the flow of events, whenever you've got a bridge component that connects on your page and you send an event, it will send it through to the bridge. There's a bridge class on the web, bridge class on the native side. It's the glue that Strada creates between the two, and the message will end up in your bridge component. When the native side replies back to the original message, it will just go in reverse. So it will go from your native bridge component back through the bridge and to your web bridge component. This is a nice example of progressive enhancement. You can start out with purely web, everything in your WebView, and layer on native features as you go. One of the cool things here is you've already built your web component, you've built your native component. Those are cleanly separated from your app features. So all you have to do now is any form in your web app, you can add your bridge form controller attribute and add your submit target, and you're good. It'll work in any screen across your entire app, web and native. Let's look at a more advanced example. This is a screen that we have in Hey. This menu is completely driven by the web. The purple menu here doesn't know anything about any of the features that it's showing here. It only knows that it's displaying. It only knows that it's displaying a list of items with different attributes. Even the icons come from the web, so we pass along icon URLs, and that's driven by the web as well. This specific example, for the sake of the presentation, it's a little too much code to show. But we have an example in the Turbo native demo apps that's a simplified version here that I'll go through. So on this screen, you can see this open menu button. This will open up a menu that looks like this if you don't have Strada at all. One thing you can notice here, it's got a nice overlay window backdrop. However, it can't stretch across the native parts of the app. It also can't block input from the rest of the native part of the app. So you could tap the back button, for example, and you're not able to actually block the user input. It doesn't support gestures or anything like that. So let's turn this into a Strada component and turn it into something that looks like this. So let's build the web menu first. We've got we've just got a div. We've got a data controller. You notice here we've got two controllers here. One is a menu controller, and this is actually driving the functionality on the web side for the web menu that exists. And we've also got a bridge menu controller for the bridge component that we've got as well. Both of these can work together, and you can layer on, even if you're already using a stimulus controller for your web features, you can layer on a bridge component, and those can work together. And I'll show you how that works. So one of the things here, you'll notice whenever one of the web menu buttons is clicked, it will call, before the bridge component, it will show the menu show function. We're going to put the click event for the bridge component here first to give it an opportunity to show a bridge menu component if it makes sense, if the native app supports it. We're going to set up a title for the menu. So this is just says select an option. So we're going to set up a target for that. And then whenever a button is clicked on in the menu, we're going to call the menu item selected function there, which will work in the menu controller. We've also got a menu target item. This is an item for the menu controller, and for the bridge controller, we're also going to give an item target as well. So building the web component, we're going to give it the name of menu, and we're going to set up the targets, the title of the menu, and then the items in the menu as well. We've got the show function here, which will be called by the attributes that we set up on the previous slide. And what we're going to do here is we're going to say if this is enabled, so this means if the native app supports, if this component's enabled and the web app the native app supports the menu component, we're going to stop the propagation of that event, and it will no longer bubble up to the menu, the regular menu controller. And then we're going to notify the web app, we're going to notify the native app that it needs to display a menu. So let's look at how that's set up. So we're going to wrap the title target in a bridge element to get its title. We're going to make the menu items into JSON. I don't have that code here, but it's very simple. It's in the demo app that we've got. Then we're going to send a message. So we're going to send a display event message to the native app. We're going to pass along the data with title and all the items in the menu. And then we're going to set up a callback here. Whenever a menu item is tapped in the native app, we're going to extract the selected index from the reply message that was passed from the native component. And then we're going to use that selected index to get the target of the button that was tapped on the native side. And then what we're going to do is we're just going to click that. So once we click that, the menu controller that you've already set up for your web app will get invoked, and that's all you need. All right, so we set up the web component. It's going to pass a message to the native app. It's going to have an ID. It's going to have the menu component name. It's going to have the display event. It's going to have a title for the menu. And then it's also going to have all the items that are in the menu. You can see here, it's got the title and an index. The index is the index of the button in the list of buttons that you're displaying. Now let's build a native component. So this is Swift on the iOS side. We're going to extend the bridge component class. We're going to set up the name of the component, which is menu, which matches the web component. We're going to implement the onReceive function here whenever we receive messages from the web. And then we're going to handle the display event. So we're going to get the data from the message, and we are going to show the alert sheet here. So I didn't put all the code here to actually implement the sheet, but it's in our demo app if you want to look at it. We're going to present that sheet, and when an item is tapped, this onItemSelected function will get called. And then we're going to reply back to the message, the display event message, with data. Unlike what we did with the submit button one, this is actually passing data back to the web. So we're going to pass along the selected index of the item that was tapped. And that will return a message back to the web. It'll look like this. It will have the same component and event names that it did before, and it will pass along data with the selected index. So if you tap the first item, it'll pass along selected index 0. And going back to the web component, it will use that selected index to click the original button. So we have a lot of examples in Hey that we've built. We've built components to, if you're viewing an email, we've got a floating action bar that has buttons that can show menus. We've got a feature in Hey to highlight text and create clips of content. As you highlight text, it will show native UI there. We've got a flash message component, which turns your web flash messages into native UI so that you can take advantage of the platform conventions there. We've got a nav button component. This is a component that lets us arbitrarily display small icon buttons in our app bars at the tops of the app. We got an overflow menu component. This component lets us display three-dot menu in the top right of the app, and then display a menu from there for lesser common actions in the app. We've got a page component. This one's interesting. The page component actually connects on every single page in the web app, and it lets us do some nice things. On some pages, for example, we instead of showing the title of your page in the top app bar, we'll show it in large styled text in the WebView. And as you scroll the page and the page scrolls away, we will animate the title into the top app bar. And then when you scroll back down in the WebView page, it will remove the title from the app bar, and then you can see it back in the WebView again. And that's an example of a component that might be quite challenging to pull off without Strada, but we can easily pass those events to the native apps and respond accordingly. We've got a print component, so you can print emails, for example, and hey, this lets us, there's limitations in the WebView APIs on mobile and what the web app would be able to do. So this lets us natively print your emails driven by the web app. And then we've got a tricks component, which lets us set up tricks toolbars and all the actions and have native UI. We've got a lot of examples that we've built up, and we're going to work on continuing to add more demo examples on the library side as well. And that is all I have. So thank you so much.